Hi friends, so today I'm back with another beautiful problem on binary search tree. So the question is, we are given a binary tree, we have to check whether this is a BST or not. Okay, so you can think of one idea at least. At least let's just discuss the idea one. So the first idea is simple. We know the in order of a BST is sorted. So first thing is we can do the in order of this binary tree, and if this in order comes out to be sorted, then we can say it's a BST, otherwise not. So first is check if in order is sorted or not, which will require time complexity of order of n. And because you're going to traverse over the whole tree obviously, and space complexity is order of h for the recursive stack space and n for storing the in order. So this is for recursive stack space and n for storing the in order. Now can we do it any other way? Can we do it in maybe, can we save this order of n space? So there are many ideas, so I'll discuss one beautiful idea just I want to share with all of you. So the idea two, so it's a very unique and different kind of idea, that's why. So if I ask you about root of a BST, can you tell me what value can the root have? What can we have in the root? So we can have anything in the root, right? I mean, the range of this root element is minus infinity to plus infinity. It could have been any element in the world, just this root element. If I say guess a BST, you can guess any possible root, right? There is no limit to that. Okay, fantastic. Now, if I come to the left of it, if I come to this node, whatever this node is, I don't know what is this node. What can be its range? Since this node is 10, since this node is 10, 100% left subtree is smaller than that. So this node can be at max 9, correct? Because it has to be less than 10. Minimum it can be up to minus infinity. So the range of this element becomes minus infinity to 9. While on the other hand, the range of this element, since this element is 10, I don't even know what this element is, but 100% this will be greater than 10. So it will be 11 to infinity. Hope it makes sense. Now let's come to this element. Now what can this element be? Let's forget there is a 3 here. What can this element be? So whatever it is, it has to be less than 5, correct? Because in a BST, left subtree is smaller than the root value. So 100% this is going to be minimum. It can be anything, but it can be at max up to 4. Why? Let's come to this. Let's come to this. So since this root can be maximum up to 9, okay, how do I know it can be maximum to 9? Because this is left of this 10, so 100% this whole subtree has to be smaller than that. So this whole subtree's range, this range is not for this only this element, this whole subtree's range, but specifically we are defining for this one. So this element has to be greater than 5, and at max it can be 9, right? It can be anything from 5 to 9. Oh sorry, 6 to 9, because 5 is already this element, so it has to be greater than this, so 6 to 9. Now coming to this element, it has to be smaller than this 9. Minimum it can be 6, so maximum it can be 6 to 8, right? Because this one is already 9, so this side has to be smaller than this one. Make sense? Now coming to this one, this element 100% has to be smaller than this 15, so maximum it can be 14, minimum it can be 11. Okay, because if it goes below 11, then it will violate this particular node, because everything to the right of because we have a 10 at root, everything on the right subtree has to be greater than 10. So I can see it here. I'm getting these values from my parent, but I'm just showing you from the root level. So just because this range was 11 to infinity, this guy minimum value will be same, but maximum it can go up to whatever this value is minus 1. Now let's guess about this one. This has to be greater than 15 at least, because it's in the right, but maximum it can be whatever is the maximum of parent, infinity. Now let's come to this 9. This 9, this has to be less than 20, so at max it can be 19, but minimum it can be what? Minimum it can be 16 from the parent. It could have been anything from 16 to 19, and that is fine. Now coming to this node, this can be what? This has to be greater than 13, So at minimum it can be 14, and at max also I'm taking it from the parent, it can be 14 only. So there was no other option for this node. Now this this range I will keep on passing to every node, and whichever node first violates it, I know, I mean, if any node violates it, we know it's not a BST. For example, this node was supposed to be in between 16 to 19, but it's 9, so it means 100% this is not a BST because of this node. Hope it makes sense. So let's just write this function. Bool is BST, and I'm given the root node and the range of this one. When initially we call this function with the root guy, start and end would be what? This will be, I mean, the smaller value could be minus infinity, which is in our case int dot minimum, and end could be int dot maximum.